Decades ago, two people accidentally proved the Big Bang. Two astronomers borrowed an antenna and pointed it at the Milky Way. But they had a problem that was keeping them from their work. The radio detector was always emitting a strange, faint hum. To continue their investigations, they had to find out where the interference was coming from. A whole year passed as they tried to solve the mystery. After ensuring that everything was technically sound, they realized the device was receiving some mysterious radiation. The question was, from where? The first idea was a foreign planet, and the second idea was military activities on Earth. But neither was the case, because no matter where they pointed the antenna, this noise persisted. The two were about to give up when the future Nobel Prize winners had one last idea: bird droppings. Since the antenna was outside, it was naturally no longer clean. But even after hours of scrubbing, this strange signal remained. Coincidentally, at the same time, a scientist hypothesized a universe that was very dense and hot at the beginning. When he heard about the noise, he knew it was the proof for his theory, and thus for the Big Bang. Thus, the expansion and cooling of the universe were proven, but the Nobel Prize later went not to him but to the two astronomers. So where does this radiation come from? At the beginning, shortly after the Big Bang, the universe was small, dense, and hot. It was full of particles and radiation, but there were no atoms yet. Every time an electron began to orbit a proton, which would form a hydrogen atom, it was shot away by light. But the universe expanded, and eventually, there came a point when the light was so spread out that it no longer had enough energy to prevent the formation of atoms. Every electron that found a proton became so firmly bonded that it no longer interacted with the light. Thus, all the light stopped bouncing off anything and just traveled straight. Today, this light is still detectable everywhere in the universe. This oldest light in the universe, which witnessed the formation of the planets, is what we call the cosmic microwave background radiation. Unfortunately, it is no longer visible radiation because, with the expansion of the universe, its wavelength also stretched. What was once visible light became infrared waves and then microwaves. But because radio broadcasts also transmit at roughly this wavelength, we can still see this radiation in a way. So next time you can't decide on one of the highbrow programs on TV, tune in to the Big Bang. If you set a channel that only shows static noise, 1% of that noise comes from cosmic background radiation.